Hello dear friends, in the last video we discussed about batteries, nothing but cells. In that we learned about primary cells as well as secondary cells. Right, in today's class, that is lecture number 19, we will start with fuel cells. But before we will going to start fuel cells, in the last video for a nickel cadmium cell, then its cell potential you just make it as 1.4 volts. Right. Now we'll continue hydrogen oxygen fuel cell. First we'll see the exact definition of fuel cell. See here, the galvanic cells. Fuel cells also type of galvanic cells only. The galvanic cells which are designed to convert energy of combustion of fuels like hydrogen, methane, methanol as well as carbon monoxide directly into electrical energy called as fuel cells. I'll repeat, the galvanic cells. The galvanic cells which are designed, specially designed to convert combustion energy of combustion of fuels like hydrogen, methane, methanol, carbon monoxide directly into electrical energy. Means in fuel cells what happens? Combustion energy is converted into electrical energy. That is a phenomena. Combustion energy of fuels into electrical energy. That's why this type of cells are called as fuel cells. According to our syllabus, we have to discuss about hydrogen oxygen fuel cell. Right, but before we will going to start hydrogen oxygen fuel cell, generally if you use a direct direct process, only 40% of combustion energy will be converted into electrical energy. But when we are using a particularly fuel cells, then almost 70% of combustion energy will be converted into electrical energy. Means no more wastage of energy here. Right. Now we will discuss about hydrogen oxygen fuel cell. For that purpose, one rough diagram given to you. See here. Here, this one and this one, these two are graphite plates, and in that graphite plates, those graphite plates are incorporated with either platinum or palladium metals to increase the rate of reaction, and both graphite plates are acting as electrodes. Right. In between both electrodes, one solution we have taken, that is aqueous, or we can write concentrated aqueous NaOH we are using as an electrolyte. That electrolyte is placed between these two electrodes. Right. Now one side we are sending hydrogen gas and the other side we are sending oxygen gas. Then the graphite plate which is in contact with hydrogen gas is acting as anode. This is anode. Next, the graphite plate which is in contact with oxygen gas is acting as cathode. See here also electricity is producing. That's why anode will be designated with a minus, cathode will be designated with a plus sign. Once again, these two are graphite plates. Those graphite plates are incorporated with either platinum or palladium metals just to increase the rate of reaction. Next, and the graphite plate which is in contact with hydrogen gas is acting as anode, and the graphite plate which is in contact with the oxygen gas is acting as cathode. And between cathode and anode we have taken an electrolyte, that is concentrated aqueous NaOH solution. Right. Here what happens? How electricity is generated? What happens? Let's see now. Here anode reaction. Through anode, hydrogen gas we are sending, and this hydrogen gas in the presence of electrolyte, how it is undergoing oxidation, we'll see here. Hydrogen, OH minus is of course part of electrolyte. OH minus is part of electrolyte only. H2 plus OH minus converted to H2O, and electrons are releasing. Balancing purpose 2H2, 4OH minus, 4H2O, 4 electrons have taken. I'll repeat. hydrogen. In the presence of an electrolyte undergoing oxidation, after oxidation water molecules are forming and electrons are releasing. Cathode. Cathode, see here again, oxygen also in the presence of an electrolyte. In the presence of an electrolyte undergoing a reduction. The oxygen also in the presence of an electrolyte. H2O is part and parcel of electrolyte. Why? Because we have used the word aqueous. Okay, oxygen in the presence of an electrolyte undergoing a reduction, taking electrons converted to OH minus. Balancing purpose 2 H2O and 4 electrons, 4 OH minus have taken. See here, what we have to do, very simple. Anode oxidation is taking place, cathode reduction is taking place. How to remember? Trick means anode oxidation. Oxidation is nothing but loss of electrons. Loss of electrons means compulsory product side negative sign will be there. Product side negative sign will be there means to balance that reactant side also negative sign we have to write. Negative sign means OH minus ion we have to take. Next, as far as cathode is concerned, here gaining of electrons. Gaining of electrons means we are taking electron. Electron is a negative charge. Reactant side negative charge is there. If reactant side negative charge, product side also negative charge should be there. Therefore, we have taken here OH minus. Like that, you just remember in the form of one trick. Then, right. Now, both we are adding. When we are adding both the reactions, then electrons first we have to cancel. There are 4 electrons are cancelled. Along with that 4 OH minus atoms also cancelled. Remaining things are 2H2 plus O2. Next important point is here product side 4 H2O molecules are there, reactant side 2 H2O molecules are there. If a product side as well as a reactant side same number of H2O molecules are present, then generally will cancel them. But here same number of water molecules are not present. In this case what we have to do, very simple, higher molecules minus lower molecules are higher member minus lower member, that is nothing but 4 minus 2, remaining is 2. That remaining things, remaining molecules will write at higher member side only. Higher member side means product side only we have to write, that is 4H2O minus 2H2O, remaining 2H2O molecules directly will write as 2H2O product side only. No need to show both the reactant side as well as the product side. In this situation, always remember higher molecules minus lower molecules, remaining molecules will write at higher molecules side only. That's it. Therefore, 2H2O plus O2 gives 2H2O, or the entire reaction if you divide with 2, you will get H2 plus half O2 gives H2O. Means ultimately we are getting a water molecule also. That also we have shown in the diagram. Then it is an outlet for water molecule. This is outlet for a water molecule. Right. Due to movement of electrons from anode to cathode, current produces, and at the same time water vapors also produced from this H2O2 fuel cell. Next, here important thing is H2O2 fuel cell efficiency is very high, and this hydrogen oxygen fuel cell, it will not stop automatically up to, see, when we are supplying hydrogen gas as well as oxygen gas continuously, cell work will not stop. Right. Next, here one more important thing is this hydrogen oxygen fuel cell has used in Apollo space program. Apollo space shuttle, this hydrogen oxygen fuel cell they have used. Why? Because to produce a current as well as to get water for drinking purpose by the astronauts. Why? Because after completion of the process we are getting water vapors. Those water vapors are condensed and used for drinking purpose by the astronauts. Right. This is about hydrogen oxygen fuel cell. Here anode oxidation is taking place, loss of electron. Cathode reduction is taking place, gain of electrons. This is about fuel cells. Right. Now we will see one small formula regarding this fuel cell. Efficiency of cell. Efficiency of fuel cell will be indicated with eta is equals to work done delta G divided by enthalpy of combustion delta H. Then delta G is nothing but minus NF E cell minus NF cell potential divided by delta H. This is efficiency formula. Right. Next we'll start the last topic of this lesson, that is corrosion. Right. Corrosion, nothing but rust. Its meaning. Otherwise, I'll give you directly its definition. The definition I'll write here. That is the loss of metal in the form of its compounds due to chemical attack on the surface of metal by the environmental constituents is called corrosion. Right. We'll try to understand the definition. The loss of metal means due to corrosion, definitely metal undergoes loss. Nothing but metal weight decreases. The loss of metal in the form of its compound only. Metal is losing its weight in the form of its compound. In the form of its compounds due to chemical attack on the surface of metal by the environmental constituents. One general example, if you see, suppose if it is iron metal, then the iron metal, if you expose to air, when iron metal exposed to air, after some time what happens, then this oxygen as well as iron both will be reacted and converted as Fe2O3. Of course, Fe2O3 is a compound of iron only. Fe2O3 is compound of iron only. Because of formation of Fe2O3, iron weight will be decreases. That is only called as corrosion. Means the metal weight is losing. How it is losing? We'll see then once again. The loss of metal in the form of its compounds. Then Fe2O3 is one of the compound of iron only. Because of formation of this compound, its weight will be reduced. This phenomena itself is called as corrosion. Right. Now corrosion purpose, different examples are there. The best example is rusting of iron as well as tailing of mercury. In our syllabus, we have rusting of iron, mechanism has given. We'll see that mechanism. Rusting of iron. Rusting of iron. Right. Then question arises then. Rusting of iron. Why this corrosion? Nothing but rusting of iron phenomena we have to learn in electrochemistry lesson. What is the relation between electrochemistry, electrochemical cells as well as this rusting phenomena? Right. See here. Now here in the rusting process, iron, when exposed to air, oxygen, what happened? Both undergoing a reaction to each other. Because of that reaction only, you will get a corresponding compound, that is ferric oxide is obtained. That itself is nothing but a rust. Because of that rust formation, its weight will be reduced. Then when both are reacted to each other, question arises then, which species undergoing oxidation and which species undergoing reduction? Very simple. When we are comparing both the substances, we have to check their SRP values. E0 E naught Fe plus 2 oblique Fe. Iron SRP value minus 0.44 volts. As well as oxygen SRP value O2 oblique H2O. Oxygen SRP value 1.23 volts. We'll just observe the values. Iron SRP value minus 0.44 and oxygen SRP value 1.23. Then out of these two, which one is a bigger value? Oxygen is bigger value, iron is a smaller value. Then already we have learned in the previous classes, the species whose SRP value is very less undergoes oxidation. The species whose SRP value is more undergoes reduction. Means during the rusting phenomena, many tiny voltaic cells will be generated. Why? Because rusting is absolutely electrochemical phenomena. Electrochemical phenomena means just like in galvanic cell, how oxidation and reductions are taking place, in rusting phenomena also oxidation and reduction processes are taking place. But of course, this rusting process is very slow process. That's why how oxidation as well as reductions are taking place, I'll show along with their proper reactions. Now here what happened? Iron undergoes oxidation and oxygen undergoing reduction. Why? Because iron SRP value is very less, oxygen SRP value is more. Right, we'll see now it's a proper mechanism of rusting. Then iron, balancing purpose I am taking 2, by losing electrons converted to Fe plus 2. It is absolutely balanced on both the sides. There are 2 Fe, 2 Fe. Left side charge is 0, right side 2 to the 4. 2 to the 4 plus 4, it is a minus 4, of course 0. And already known to you it's a SRP value E naught. Fe plus 2 oblique Fe. See the symbol, Fe plus 2 converted to Fe. Nothing but a reduction symbol as given. And of course oxidation is taking place. Regarding this, we have learned in our previous classes, SRP value reduction symbol has shown nothing but its SRP value minus 0.44 volts. Now we write oxygen. Now oxygen in the presence of electrolyte. Now what is electrolyte? Electrolyte means here moisture as well as carbon dioxide both will react to each other. You will get H2CO3. In that H2CO3, H plus will act as electrolyte as well as catalyst. That's why O2 in the presence of H plus undergoing reduction because its SRP is more, and you will get H2O. Balancing purpose will write 4 plus 4 electrons gives 2 H2O. And already known to you E naught O2 oblique H2O value 1.23 volts. Means when iron as well as environmental constituents, nothing but air, when iron as well as air are exposed to each other, definitely iron undergoing oxidation being less SRP, oxygen undergoing reduction being more SRP. Now we'll add both the reactions, then we'll get the overall reaction is obtained. We cannot say here cell, of course. Okay, overall cell reaction is not of course proper word. Overall reaction, that's it. Then now 4 electrons, then you will get 2 Fe plus O2 plus 4H plus gives 2 Fe plus 2 plus 2 H2O. Means initially what happened? Iron due to exposure with oxygen converted to ferrous ion, 0 oxidation number is converted to plus 2, means iron is undergoing of course oxidation. Right, next stage ferrous will be converted into ferric. How ferrous is again undergoing oxidation and how again it is undergoing again it is converted to ferric, we'll see in the next step. See here, I'll write same both the substances as it is, 2 Fe plus 2 plus 2 H2O in the presence of environmental oxygen further undergoing oxidation. Ferrous further undergoing oxidation, and you will get Fe2O3 plus 4H plus is coming out, because H plus we are using as a catalyst. Already you know that catalyst never consume in the reaction, it just speed up the reaction, and after completion of the reaction catalyst as it is will come out. Okay, that's why 4H plus. Now ferrous has converted to ferric, nothing but here oxidation number is Fe plus 3. Okay, next thing is finally Fe2O3 ferric oxide undergoes hydration with water. It is reacted in the environmental constituents only. Hydration is taking place, and finally you will get Fe2O3XH2O. This compound only called as rust. That's it. Rust formula. Hydrated ferric oxide. Hydrated ferric oxide itself is called as rust. Here iron oxidation number is plus 3. Initially it was 0, has converted to plus 3. Means iron undergoes oxidation, that itself called as corrosion, nothing but rusting. Once again, here what happened? Iron has exposed to air. When iron is exposed to air, what happened? Being less SRP, iron undergoing oxidation. Being more SRP, oxygen is undergoing reduction in the presence of an electrolyte. What is electrolyte? Moisture plus carbon dioxide will get carbonic acid. Carbonic acid is giving H plus ion. That H plus is acting as an electrolyte as well as a catalyst. Then converted to H2O. And when we are adding the reactions, we can cancel the electrons. We will get overall reaction. Next, what happened? Here ferrous only obtained. This ferrous again in the presence of atmospheric oxygen, further undergoing oxidation, ferric oxide is obtained. This ferric oxide is hydrated, and finally hydrated ferric oxide is obtained. This hydrated ferric oxide itself is called as rust. See here, initially it was a pure iron. Pure iron has converted into its compound. Ferric oxide is absolutely its compound only. Because of formation of its compound, then it undergoes rusting, nothing but corrosion. That's it. Next we will discuss about how to prevent this rusting, nothing but corrosion. We'll see different methods, prevention methods. Prevention methods. Right. In that first prevention method is barrier protection. Barrier protection. Very simple. What is barrier protection? Means if it is iron metal or any metal, then this iron metal, if it is exposed to air, atmospheric air, definitely undergoing the corrosion. That's why we have to prevent the exposure of this metal with the environmental constituents. For that purpose, on its surface, some coating we have to do that. Which coating? Like paint, varnish, grease, etc. Coating if you do, then that coat will prevent direct contact of metal as well as environmental constituent. Means if it is iron, if it is oxygen, now there is no any direct contact between them. Then this painting or grease or varnish will act as a barrier between metal as well as oxygen. It is called as barrier protection. Second one is sacrificial protection. Sacrificial protection. What is meant by sacrificial protection? Very simple. Suppose if it is iron piece, we have to protect this iron from the rusting. Immediately what we have to do? See here, iron SRP value is minus 0.44 volts. Next, zinc SRP value minus 0.76, right? When we are comparing iron as well as zinc, iron SRP value is more, zinc SRP value is less. Then our target is we have to protect this iron. Because of that, here on this iron surface, then we have to keep still less SRP metal we have to keep on its surface. Means I am just placing a zinc on its surface. That's why what happened now, when iron as well as zinc both are compared to each other, zinc being a less SRP value easily undergoing corrosion, nothing but easily undergoing oxidation. Oxidation is nothing but here corrosion only. That's why because of less SRP, zinc undergoes oxidation and finally zinc undergoing corrosion. But iron is safe inside. That is nothing but sacrificial production. Means here zinc is sacrificing for iron purpose. That's it. Next, third one is cathodic protection. Cathodic protection. Cathodic protection. Very simple. What is cathodic protection? Means again, for example, it is a zinc. Again, you have to suppose if it is iron. If it is iron, our target is again we have to protect the iron. Now, for that purpose, what we have to do? Then this iron again we have to connect to this iron. We have to connect to still less SRP element. Metal we have to connect. When it is connected to still less SRP, and definitely when you are comparing to each other, being more SRP, iron acts as cathode and zinc acts as anode. Then already know to you, the species or the electrode which acts as anode undergoes oxidation. Means zinc undergoes oxidation. Zinc undergoes oxidation. Because of oxidation of zinc, zinc itself undergoes corrosion. Then our iron is safe side because we have made it as cathode. Because at cathode no more oxidation. Because of that reason, iron is safe inside because it is turned as cathode. It is turned as cathode. How it is turning as cathode means if it is connected with still less SRP or more reactive metal, definitely less SRP metal is acting as anode, undergoes oxidation, undergoes corrosion, but our required metal is in safe side, right? And finally, fourth one is using of anti-rust solutions. That's it. Using of anti-rust solutions, then we can protect from corrosion process. One is barrier protection, one is sacrificial protection, and the third one is cathodic protection, and the fourth one is anti-rust solutions. Right. And this sacrificial protection is also called as galvanizing process. Right. Next, from this we have completed the entire electrochemistry topic. Then before we're going to stop the today's class, we'll just recall this March 2020 annual examination questions. Right. In the first question is what is a secondary cell? What is secondary cell? Question mark. This for 1 mark. In yesterday's class only we have discussed what is a secondary cell. How to define a secondary cell? Means the cells which can be rechargeable and can be reused are called as a secondary cells. Enough? Okay? Right. Next question is a solution of nickel nitrate is electrolyzed, let here March 2020, electrolyzed between platinum electrodes using a current of 5 amperes for 20 minutes 20 minutes. What is the mass of nickel deposited at cathode? In the brackets given molar mass of nickel is equals to 58.7. This is the question. First we'll try to understand the question. Here a solution of nickel nitrate is electrolyzed between platinum electrodes, nothing but inert electrodes, using a current of 5 amperes for 20 minutes. And what is the mass of nickel deposited? Mass of nickel is nothing but Faraday's first law we have to use here. Like this we have solved many problems. Okay, we'll see the next solution part. We'll write its given data. Then 5 amperes, I value is 5 amperes. Then T is 20 minutes has given. If a current is in amperes, the time should be in seconds. That's why 20 into 60 seconds I'll write. Seconds. Next will W of nickel is question mark. And here one more thing, that is equivalent weight of nickel is needed. For that purpose only molar mass, atomic mass of nickel has given. Therefore equivalent mass purpose, atomic mass divided by valency, 58.7 divided by valency of nickel. Then valency of nickel, how to know? For that purpose he has given nickel nitrate. If you split this nickel nitrate, nickel is getting a +2 charge. Therefore its valence is 2. And if you simplify the value, you will get 29.35. 29.35. Now we'll take our main formula. W of nickel is equals to equivalent mass of nickel divided by 96,487 into I into T is the formula. That is a 29.35 divided by 96,487 into I, current in amperes 5, into time in second 20 into 60. That's it. And if you simplify, you will get 1.825 grams. Your answer is 1.825 grams is your answer. Means that much mass of nickel will be deposited at cathode. Very simple. I given, T given, mass is asking, and equivalent mass indirectly has given, that we have calculated, and we have used Faraday's first law formula. W is equals to E by 96,487 into I into T, and after substitution you will get answer. Right. Next question. Next question is like this. Calculate the EMF of the cell in which the following reactions takes place. Now I'll give you the reaction. This is also given the question only. Ni plus 2Ag plus, its concentration is 0.002 molar, gives Ni plus 2 0.160 molar plus 2Ag, and E0 cell value given 1.05 volts, right? This is the question. Is asking cell potential. Cell potential is asking. See here, calculate the EMF, nothing but cell potential, EMF of the cell in which the following reaction is taking place. First, we'll try to understand the reaction. Here, nickel elemental state 0 converted to plus 2 means nickel undergoing oxidation, and Ag plus undergoing a reduction. But here, luckily, complete E0 cell value has given in the question only. Directly E0 cell given, no need to calculate. Now we'll write a Nernst equation for cell potential, that is E cell is equals to E naught cell minus 0.059 by n log base 10 product concentration by reactant concentration. Where we will get the product by reactant means we will get in the net cell reaction only. Here fortunately in the question net cell reaction has given these two are the reactants as well as these two are the products. That too will take only ion concentration only will take. That's why Ni plus 2 product means Ni plus 2. I'll write directly Ni plus 2 divided by reactant concentration Ag plus, but before Ag we will have 2 moles. Whatever the coefficients are there, those coefficients will be raised as its power. That's it. Now we'll just substitute the values. E naught cell value is 1.05 minus 0.059 by n. How many moles of electrons involved in this process means very simple. 0 converted to plus 2. That's it. 2. No need to see other thing. Other equation. Log base 10 Ni plus 2. Ni plus 2 concentration is 0.160 divided by Ag plus 0.002 whole square. This you have to write. Many of students will miss this 2 number. Whole square they have missed in the last year also. I observed. Compulsory Ag plus square means whatever the value is given, that square we have to write. That is equals to 1.05 minus 0.0. If you divide 295 log base 10, if you simplify the entire value, you will get 4 into 10 is to 4. 4 into 10 to the power of 4. This is mathematical calculation. That is your job. You have to do that. 1.05 minus 0.0295 log m into n formula. Log m log 4 plus log n 10 to the power of 4. Log m plus log n, of course base 10 that is fixed. Next, that is equal to 1.05 minus 0.0295. Next, log 4 value 0.6020. 0.6020. Next, again one more formula, log m to the power of n. Log m to the power of n is nothing but n log m, nothing but 4 log base 10. 4 log 10 base 10. 4 log 10 base 10 is 1. 4 into 1 is 4. Write directly 4. 1.05 minus 0.0295, and if you add, you will get 4.6020. And if you do, first we have to multiply these two values, and whatever the value you will get, and you have to subtract from 1.05 and the final answer. Otherwise, we'll write that value also. 1.05 minus, if you multiply, you will get 0.135, and if you subtract, the final answer is 0.914 nearly. E cell 0.914 volts is our answer, right? Very simple. First we'll here in the question directly net cell reaction given. Suppose if a net cell reaction has not given, then we have to write a net cell reaction by seeing the symbol. Cell notation we have to see. With the help of that cell notation, we have to write a net cell reaction. Without a net cell reaction, it is bit difficulty to identify which is a product, which is reactant. Because in our formula, we will write a product by reactant. We will get a product by reactants only in the net cell reaction. That's it. That's why Ni plus 2 by Ag plus whole square. One is a product, one is a reactant, and if you substitute and if you calculate, you will get answer. Right. Next question. Next question, he has asked state Corrosion law of independent migration of ions. Independent migration of ions. Of course, Corrosion law we have learned clearly in our last videos. Please go through that videos. And the next question is, what is meant by limiting the molar conductivity? Limiting molar conductivity. This also we have learned clearly in our last video. That's why please go through all the videos clearly. And if you observe previous questions, then there is no any new question to us. All the questions as well as all the concepts, line to line as well as word to word we have covered. Whatever the given in the NCERT book. More than that also, like CET points, like NEET points also we have covered in our electrochemistry lesson. I think you people are satisfied with my teaching. And if you are having any doubts, please feel free to call me by taking number in our college office room. Thank you for your watching. Thank you. Bye.